Welcome everyone, myself Dr. Sujata Kulhe. In this video, we are going to see various properties of task environments and different types of agents. In the previous video, we have seen what is an agent and what is the definition of. In the previous video, we have seen what do you mean by agent and what is the rational agent. Now, we also have seen that if you keep the agent in a different environment, its performance will change. For example, if you keep the vacuum cleaner machine in the windy rooms, then its environment is going to change and it require different actuators sensors, and accordingly the performance measures will also change. Similarly, if you allow the taxi driver agent to drive a car on a plain road, it will drive smoothly. In contrast to this, if you allow the taxi driver agent to drive a car in the traffic, in that case, the environment is going to change, the actuators, sensors, and performance measure will also change. So, the range of task environments that might arise in AI is very vast. However, we can identify small number of dimensions along which task environments can be categorized. These dimensions will determine the appropriate agent design. So, these dimensions are also called as the properties of task environment. So, what are the different properties of task environment? The environment can be fully observable or partially observable. It can be deterministic or stochastic. It can be episodic or sequential. It can be static or dynamic, discrete or continuous, single agent versus multi-agent. The real world is partially observable, stochastic, sequential, dynamic, continuous, and multi-agent. Really, it is very challenging job to design an agent which would work in the real world. Let us see various task environments one by one. First task environment is fully observable. If an agent sensors give it access to the complete state of the environment at each point of time, then we can say the task environment is fully observable. A task environment is effectively fully observable if the sensors detect all aspects that are relevant to the choice of action. Relevance in turn depends on the performance measure. Now, fully observable environments are convenient because the agent need not maintain any internal state of the world. Now, the environment might be partially observable too. If the agent sensor does not give the access to the complete state of environment, such an environment is called as partially observable environment. To understand this, we will see the examples of environments. The chess game is an example of fully observable environment because whatever board or whatever objects are there on the board are visible to the agent. So it is called as fully observable environment. In contrast to this, if you consider the game of poker, it is a card game. In this game, you cannot see the opponent player's card. The cards are hidden and agent cannot see the hands of opponent. So, such an environment is called as your partially observable environment. Similarly, you can consider an example, a vacuum cleaner agent with only a lower local dirt sensor cannot tell whether there is a dirt in other squares or not. And an automated taxi driver agent cannot see what other drivers are thinking. So, these two examples can be considered for partially observable environments. Next environment is deterministic environment or stochastic environment. If the next state of the environment is completely determined by the current state and the actions executed by the agent, then we can say the environment is deterministic. Otherwise, it is considered to be a stochastic. We have to remember, if the next state is completely determined, then only the environment is deterministic. If you could not determine what may be the next state of the environment, such an environment is the stochastic environment. In the stochastic environment, there are multiple predictable outcomes. Now, to understand the deterministic environment and stochastic environment, we will consider an example of image analysis system. In the image analysis system, one has to analyze the image, and based on that, it has to take the decision and provide the summary. Now here, the image is completely visible to you, and the next state of the environment is not going to change, or it is deterministic. You can easily determine what may be the next state of the image analysis system. So, such an example can be considered for deterministic environment. If the environment is partially observable, then it appears to be a stochastic environment. To consider the stochastic environment, we will see an example of taxi driver. Taxi driving is clearly a stochastic in the sense because no one can predict the behavior of the traffic exactly. In between, someone's tires blow or someone's engine seizes without any warning in the middle of the road. So, you cannot determine what may be the next state of the environment. Similarly, you can also see an example of Ludo game. In the Ludo game, you cannot see what may be the next state because you have unpredictable outcomes, because you have to throw the dice. Based on that, you have to take the action. So the outcomes are unpredictable. Such an environment is called as the stochastic environment. If the environment is deterministic except for the actions of other agent, we say the environment is strategic. For example, chess. The players and the next state of the board is strategically determined by the player's action. The players would define the strategy, and based on that, they are going to take an action. So, such an environment is called as the strategic environment. To understand strategic environment, chess is the best example. The vacuum cleaner world, as we earlier seen, is deterministic, but variations can include stochastic elements like randomly appearing dirt and unreliable suction mechanism. So, you can consider the world for the vacuum cleaner as stochastic. The next environment type is episodic versus sequential environment. In an episodic task environment, the agent's experience is divided into atomic episodes. The agent's experience is divided into atomic episode. Each episode consists of the agent perceiving and then performing a single action. Such an environment is called as the episodic environment. In the episodic environment, subsequent episodes do not depend on what actions occurred in the previous episodes. Many classification tasks are episodic. We can consider an example of classifying the images. In the classification of images, one has to classify an image in class A. After classifying an image, one has to classify another image in class B. Similarly, you can classify n images. Classification of one image is called as one episode. Classification of one image is not dependent on the classification of another image. So, it is an best example for episodic environment. Similarly, you can consider an example of part picking robot. Part picking robot also picks a particular part or damaged part and put it in a particular bin. Checking or detecting the defective part which is coming for next time or delayed by some time, in that case you cannot it is not going to affect the detection of early damaged part. So the agent that has to spot detective that has to spot detect defective parts on an assembly line bases each decision on the current part regardless of the previous decision. Moreover, the current decision doesn't affect whether the next part is defective or not. In contrast to this, we'll see the sequential environment. In the sequential environment, the agent engages in a series of connected episodes. That is, one episode is connected to the another episode. Playing chess and taxi driving are considered to be an episodic environment because in chess, when you make one move, the next move is dependent on this move. Similarly, in taxi driver agent also, when you are making a particular move, the next move is dependent on the previous move. Episodic environments are simpler than the sequential environments because agent does not need to think ahead. Next environment, next environment is static environment versus dynamic environment. If the environment can change while an agent is deliberating, then we can say the environment is dynamic for that agent. Otherwise, it is considered to be a static. Now, what do you mean by agent is deliberating? When agent senses from the environment, it makes the decision based on what it has sensed. While it is making a decision, that time is called as your deliberating. Static environments are easy to deal with because the agent need not to keep looking at the world while it is deciding on an action. And in contrast to this, dynamic environments will change when the agent is deliberating. So it is difficult to work in the dynamic environment. Taxi driver agent is clearly a dynamic agent. The other cars and taxi itself keep moving while the driving algorithm calibrates or it thinks what to do next. One more example is there for the dynamic environment, that is interactive tutor. So the environment for interactive tutor, the environment are students. So the thinking of the student changes whenever an agent is teaching. So this situation is called as your dynamic environment. Chess, when played with a clock, is a semi-dynamic environment. Crossword puzzle are the example of static environments. So the uh, taxi the environment itself does not change with the passage of time, but the agent performance score does. Then we say that the environment is semi dynamic. You have to remember that if the environment is not changing itself with the passage of time, but the agent's performance score is changing, that's why such an environment is called as the semi dynamic environment. Chess, when played with clock, is the example of semi dynamic environment. Next environment is discrete one environment versus continuous environment. The discrete environment and continuous environment distinctions can be applied to the state of environment, to the way time is handled, and to the percepts and actions of the agent. For example, a discrete state environment such as chess game has a finite number of distinct states. That is, suppose you are changing the position of a pawn. This is a discrete movement. It is not a continuous. In contrast to this, taxi driving agent is a continuous state and it is a continuous time problem. The speed, the location of the taxi, and other vehicles are going through the range of continuous values do so smoothly over the time. So, taxi driving agent is called as your continuous environment. Now, you can say that in the taxi driver agent, there may be an input considered, which is suppose audio input or some digital cameras are going to give you the input. So you can say that the digital cameras are discrete. Strictly speaking, yes, digital cameras are discrete, but it is typically treated as representing continuously varying intensities and locations. That is, it is used for other purpose. So taxi driver is a continuous process where you have to do multiple actions. In chess, you have to do multiple actions but in discrete manner. Playing the crossword is again a discrete environment. Similarly, interactive English tutor can be considered as an discrete environment because you finishes or the teacher finishes first chapter, then the next chapter, and then the next chapter. So you can consider it as an discrete environment. The next environment is single agent or multi-agent environment. The distinction between the single agent and multi-agent environment may seem simple enough. For example, an agent which is solving a crossword puzzle is a single agent environment, whereas a game where multiple players are playing football can be considered as a multi-agent environment. So, if the environment that contains other intelligent agents, the agent needs to be concerned about the strategic, game theoretic aspects of the environment. Based on this, we can have two types of environments in the multi-agent scenario: cooperative environment or competitive environment. If we consider an example of a game, in the game environment, A and B player, both the players are playing the game and both the players want to win the game. Such an environment is called as the competitive environment. In contrast to this, in taxi driver agent, suppose taxi driver agent is driving a taxi. Beside him, one more agent is driving the taxi. So does an agent A has to treat an object B or another taxi as an agent, or it should consider it as an stochastically behaving object. The key distinction is If B's behavior is best described as maximizing a performance measure whose value depends on A's behavior. In chess, the opponent entity B is trying to maximize its performance measure with by rules and the with by rules of chess. It minimizes the agent's A performance. So this environment is called as your competitive. But as we have seen in taxi driver agent, suppose both the agents are driving a taxi. In that case, their performance measure is do not collide to each other. Because of this performance measure, they are working in an cooperative manner. So they such an environment is called as your cooperative multi-agent environment. Most engineering environments don't have multi-agent properties, whereas most social and economic systems get their complexity from the interaction of rational agents. So sometimes one more example we can give, partially competitive example for the multi-agent scenario for the taxi driver agent. Why it is partially competitive? Because suppose two agents are driving a taxi and there is only one parking lot available. In that case, there is a competition. But it is a partial competition because their basic goal is to do not collide. So the agent design problem arising in multi-agent environments are often quite different from those in single agent environment, because in multi-agent environments the agent has to communicate to each other. So these were the various types of environments. We have seen various environments. One might expect the hardest case is partially observable environment, stochastic environment, sequential environment, dynamic, continuous and multi-agent scenario. This may be the toughest environments. We can see various agents having various task environment properties. So the first agent is the crossword puzzle. The agent which is going to solve the crossword puzzle. Observability is full because whatever puzzle is there, that is clearly visible to the agent. It is deterministic because the next move you can determine what may be the next move. Since it is fully observable, it is deterministic too. It is a sequential environment because one puzzle or one word can solve the another word. So it is a sequential process. The environment is not going to change when the agent is deliberating. So this is called as a static environment. When you solve or when you guess first word, then you try to guess the next word. So guessing one word is a discrete move. Single agent is going to perform in the crossword puzzle. Next example is chess with a clock. When you use or when you play chess with a clock, there is a limitation on time. Since everything is visible to you, that is the board and the objects on the boards are visible to you, the environment is called as the observable, fully observable environment. But sometimes what is going on in the opponent's mind that you cannot observe. That's why the environment is a strategic environment, because the what is going on in the opponent's mind is not fully observable to you, so it is partially observable, and since it is partially observable, you cannot determine what may be the next step, and next step can be determined based on the strategy. So it is called as a strategic environment. It uses a sequential approach because you make a move, then opponent make a move, then you make a move, like this till the checkmate is there. Next is static environment. Now here the environment is semi-static because the clock is introduced, so the environment is semi-static. It is a discrete move because you are making a move, then pause, then making a move. And it is a multi-agent scenario. The next game is a poker game. Poker is any of a number of card games in which the players wager over which hand is best according to some rules. So in this game, naturally it is a card game, so the environment is partially observable. Since it is partially observable, the environment can be a stochastic environment. And it is a sequential process. The environment is not going to change when you are deliberating or when the agent is deliberating, so it is static. If you make a move, then the opponent will make a move, so it is a discrete environment, and multiple players are there, so multi-agent environment. Similarly, next game is the backgammon game. It is one of the oldest known board games. So in this game, it is a two-player game where each player has 15 pieces that you have to move between 24 triangles according to the roll of dice. So it is a fully observable game, but some partial information you cannot determine. It is based on your dice, so it is not a deterministic, it is stochastic. It is a sequential game and it is a static game. When the agent is sensing or performing an action, the environment is not going to change, and one player make a move, then other, so it is a discrete and multi-agent game. In case of taxi driving environment, we have already seen partially observability, stochastic, it is a sequential, it is a dynamic environment, continuous process, and multiple agents are there if other taxi drivers are considered as an agents. In medical diagnosis, the observability is partially. Now, why partially? Because many symptoms are not visible. So, you cannot observe fully the patient. Since you cannot observe the patient fully, the environment is stochastic. It is not an episodic, it is sequential because one episode may be related to another episode, because we are going to take a treatment for a particular disease. So it is an sequential approach. The environment is going to change when the agent is deliberating. Suppose you are reading something, suppose you are checking a blood pressure, and blood pressure is going to change according to time. So it is a dynamic environment. It is a continuous process. It is not a discrete movement or a discrete process. It is a continuous, and single agent can be considered. The medical diagnosis system can have multiple agents also, because the tests are being conducted by another agents, or you need a staff like sisters or compounders for help. So it can be a multi-agent scenario also. The next agent is a image analysis agent. In the image analysis agent, you have to analyze the image. Based on that, you have to give the decision. Since you can easily analyze what is an image, the observability is fully, and since you can observe it fully, nothing is hidden, the environment is deterministic. You can determine the next step. If you analyze one image, after that you will analyze the next image. So the first image analysis is considered as an one episode, and one episode is not related to the next episode. It is a semi-static environment because the environment may change. So it is a semi-static. It is a continuous process, and it is a single agent scenario. Now, why it is a continuous process? Because suppose a satellite is sending the samples in the form of images. In that case, the satellite is sending continuously the images for analysis. So it can be considered as an continuous process. And here we have considered a single agent, but there may be multiple agents also to collect the image and like that. The next task environment is part picking robot. As we have seen that part picking robot has to identify the faulty part and it has to place it in the correct bin. So the observability is partially, and the environment is stochastic since the observability is not full, so it is partial. It is an episode, that is first one part detection is an episode which is not related to the next part detection. The environment is dynamic because it is a factory layout. You can change, or there might be changes in the factory when an agent is performing an action. The it is a continuous process because there is a conveyor belt on which the parts are coming continuously, and it is a single agent. Next comes to the refinery controller. In the refinery controller, the observability is partial because many control systems are there which are not visible fully. So it is considered as an partially observable. It is, since it is a partially observable environment, it is a stochastic environment too. And in the refinery controller, this refinery controller is your sequential process. The environment is going to change, so that's why it is dynamic. It is a continuous process and single agent. Next comes to interactive English tutor. Again, the observability is partial. What is going on in other students' mind, that is not visible. Since it is not visible, the environment is stochastic. The, uh, the environment is sequential too, because one chapter is related to other chapter, so it is a sequential process. The environment is going to change when the agent is deliberating, so it is dynamic. And it is a discrete, that is teaching one chapter, then next in the next class teaching next chapter, so it is a discrete agent. And multiple agent may be there in interactive English tutor. So thus you might have got a clear idea about what are the various properties of the task environment. In the previous slides, we have seen what is an agent. An agent is an entity which will sense from the environment, and based on that sense, whatever it has sensed, that is percept history, it will perform a particular action. So the job of the AI is to design the agent program that implements the agent function mapping percepts to action. So the agent's function is mapping of percept history to the action, and to have that function we will write an agent program. Now suppose the agent program is running on some computing device with the physical sensors and actuators. We call this as an architecture. So we can see that the agent consists of the architecture, which is a physical entities, and the program, which is nothing but the agent function. So agent is equal to architecture plus program. Obviously, the program we choose has to be one that is appropriate for the architecture. Naturally, because suppose you are going to have an program that is going to recommend the actions like walking or singing. In that case, in the architecture, you should have something which has legs or which has speaker or microphone to sing. The architecture might be just an ordinary computer. It may be a robotic car with several onboard computers or chips, cameras, and other sensors. So, the basic algorithm for an rational agent we can consider as: while true, you have to percept from the sensors, you have to determine what is an best action, you have to record the action in the memory, based on that action you have to perform. This is what is an simple algorithm for an rational agent. Most of the AI programs are a variation of this theme. We are going to see various different agents which are there, or various types of agent programs that can embed the principles of almost all the intelligent system. Earlier we have seen a vacuum cleaner agent. The problem with the vacuum cleaner agent was that it was designed as an table driven agent approach. That is, whatever the percept sequence is there, based on that percept, you will design a table in which respective action is to be noted. Now, what should be the length of that table? Because no computer is there which is having an infinite memory, and cleaning the room is a continuous process. So, in this case, the table driven agent will not work. So, we have different types of agents for such a system. We are going to have the agent which is called as your simple reflex agent, or which is also called as your percept based agent. We are going to see the model based reflex agent, goal based agent, and utility based agents one by one. The first one is simple reflex agent or a percept based agent. It is a very simple type of agent. This agent selects an action on the basis of current percept, ignoring the rest of the percept history. Now here we can see this is what an environment. From the environment, the agent is going to perceive through the sensors. After it perceives through the sensors, it will come to know what the world is like now. The agent will select actions on the basis of current percept only. So whatever it has perceived from the environment, based on that, it is going to take an action. So what action it should take? The action should be taken is dependent on the condition action rule. That is, if you do so, then you have to do. If you are doing A, then the next action, if A has been sensed, then the action will be B. Based on that action, the instructions to the actuators are given, and the actuators are going to act in the environment as an action. To understand this reflex agent, we will consider an example of taxi driver agent. When a taxi driver agent is driving a car and the car in front is applying the brakes, in that case you also should apply the brake. So this is what is the condition action rule. Generally, we use rectangles to denote the current internal state of the process. We can see what is the state of a process is denoted by the rectangle, and we use the ovals to represent the background information used in the process. The simple reflex agent is based on the reflex action of a human body. Like if someone is approaching towards your eyes, automatically you will blink your eyes. Similarly, when a taxi driver agent will see that the one who is driving the car in front is applying the brake, I should also apply the brake, I should also slow down, so it will take the corresponding action. But the agent will work only if the correct decision can be made on the basis of only the current percept. That is, only if the environment is fully observable. If the environment is not fully observable, in that case the agent will not be able to find out the current state, or he will not be able to perceive properly, and the actions will not be taken. Appropriate action will not be taken. To understand this, I will again give you an example of taxi driver agent. In the taxi driver agent, if suppose you are driving a car and the car in front of you is applying the brake. Now, how do you understand that the car in front of you is applying the brake? because some car has a centralized or a center light which will indicate the brake light. Some cars has the tail lights of the tail lights, and some cars has the turn signal lights. So the taxi driver agent, if the car changes, in that case the taxi driver agent will not be able to understand what is the current state, whether the agent in front of you or in front is applying brake or not. So this kind of agent is very simple agent and will not work if the environment changes. And we know that the environment or the real world is not an observable environment, it is totally dynamic environment. So for this purpose, this particular reflex agent is going to evolve into the model based reflex agent. In the model based reflex agent, we can see the real world, or we can have a model of the real world. Model based agent is the most effective way to handle the partial observability in the environment. The partial observability is there because the environment is going to change and the environment is dynamic. So, the agent should maintain some sort of internal state that depends on the perceived history and thereby reflects at least some of the unobserved aspects of the current state. Now, again, we can see here the environment is there and the agent is going to perceive from the environment through the sensors. And after perceiving from the environment, the agent will come to know what is the world like now. But to understand fully what is the world is like now, we need to provide the model of the world. Now, what do you mean by the model of the world? Suppose we consider an example of taxi driver agent. In the taxi driver agent, suppose you are driving a car and you want to change the lane. If you wanted to change the lane, you should keep track of where the other cars are there if you cannot see them all at once. Similarly, what will happen if you apply sudden brake? If you apply sudden brake, in that case, the car which is driving behind you may dash your car. Similarly, if you wanted to move to right, in that case, you have to move your steering towards the right direction. Similarly, you have to understand that whenever you are overtaking a car, in that case, you have to be a closer behind that. So, you have to understand how the world evolves or how the world works or how you should drive the taxi. Because while driving the taxi, you have to follow the rules and regulations. So, this knowledge about how the world works is implemented in simple Boolean circuits or in complete scientific theories, which is called as the model of the world. And an agent which uses such a model is called as the model based agent. So, such a model or such a world is nothing but how the world evolves and what my actions do and what is the current state. These are going to be the input to create a particular state for an agent. After getting a perfect state, what should my action do? To understand or to decide what action should I take, again, condition action rules are there. One example we missed, that if a dangerous driver in front, then we have to keep the distance. You should also know that how the people drives the car. If the driver is dangerous, it is driving car too fast, in that case you have to keep distance. Such a things are embedded into the how the world evolves, and which will decide what the world is like now, that is the current state. Based on that, and based on the condition action rule, the agent is going to decide that what action I should do now, and based on that it is going to act in the environment. So this is what is the model based environment. And model based reflex agent or a model based agent, internal, it maintains the internal state and important information from the previous perspective. Its sensors only provide a partial picture of the environment. It is helped with some partially observable environment. The internal states reflect the agent's knowledge about the world. This knowledge is called as the model, that is how the world evolves. It may contain the information about changes in the world, that may be caused because of actions of action, or it is independent of the agent's behavior. These things we have covered. Now, just knowing about the current state of the environment is not always enough to decide what to do. Suppose you are driving a car and at the road junction, that you can turn to right, left, or you can go straight. But how you will come to know that what is the current state or what is the next action? For that purpose, the agent has to have some goal. So here there is a rise to the goal based agent. So the next agent is goal based agent. Agent has to give some goal and the agent will work in the direction of that goal. Here, goal plays an important role. The agent is going to be similar to the model based reflex agent. Only the thing change here is the model based reflex agent is provided certain goals. Now, what may be the goal for the taxi driver agent? To reach to a correct destination may be the goal. So, in order to reach to the correct destination, you have to take multiple decisions of the path. So, we'll see that how the goal based agent works. From the environment, it is going to perceive through the sensors and it will create an image of what the world is like now. To create an image, first it will give an internal state. Based on that, it will how the world evolves, and based on that, it will decide what your action will do. If what will happen if you do so. In that case, the agent has to correct. The agent has to choose the correct action, and what it will be like if I do action A. To understand this, we'll consider that a taxi is standing over there where there is a traffic signal, and you have three ways: either you can move to left or right, or you can go straight. Now, if what will happen if you move straight, what will happen if you move right, and what will happen if you move left? All this depends what is your goal. So based on your goal, you will take an action, and that action is going to act in the environment. Such a agent is called as your goal based agent. Sometimes goal based action selection is straightforward when goal satisfaction results immediately from a single action. Sometimes it will become more tricky when the agent has to consider long sequences of twists and turns to find a way to achieve the goal. Now here, to reach to a goal, we have to use various searching and planning techniques, which are the subfields of AI that we are going to study further. Now, again, we can consider one example of the taxi driver agent. A goal based agent, in principle, could reason that if a car in front of you is applying the brake, you will have to become slow. You will not have to apply the brake, because if you apply a sudden brake, then you may hit to the other car. So that's why hitting, not to hit to the other cars is one of the goal. So this is what is an advantage of goal based agent. So various goals you have to define for the agent, like a taxi driver agent, to reach to a particular destination is one of the goal, but not to hit the other cars is one of the goal. Since you have to achieve this goal, you have to understand that if the car in front of you is applying the brake, then you will have to slow down. You don't have to apply the sudden brake. So the goals are like this. In the goal based agent, you have to understand that agent tries to reach a desired state. The results of possible actions are considered with respect to the goal. It is easy when results can be related to the goal after each action. It may require consideration of the future, that is, what if scenarios. It requires searching, reasoning, and planning, that we are going to cover in the next videos. Goal, Goals alone are not really enough to generate high quality behavior in most of the environments. Like, we consider an example of taxi driver agent. In the taxi driver agent, reaching to the correct destination is one of the goal. But how you are reaching to the destination, that also matters. That is, how your taxi driver agent is driving the car. Is the taxi driver agent making you happy or not? Is the taxi driver agent making you satisfied or not? So, this gives the rise to the utility based agent. So, instead of or apart from goal, or considering the goal also and considering the utility also, the utility based agent has to work. The agent will sense from the environment through the sensors, and it will find out what is the world is like now. This will be called as an internal state. How the world evolves and what my actions do is the model of the world, which is going to decide the state. Now, what it will be like if I do action A? That means if you are driving a taxi and you apply a sudden brake, in that case, what will happen? Will my passengers be happy if I do so? That you are going to check in the next process or next box. That is, how happy I will be in such a state. If I take action A, in that case, how happy it will be in such a state. And utility is provided to this. That means, suppose if I am driving very harsh, in that case, how happy I will be in such a state. Passenger will be happy or not. And if he is happy, in that case, I should go for that action. But if he is not happy, in that case, what action I should do now? Based on that, the actuators would act in the environment. Suppose nowadays, when we book Ola or Uber taxi, in that taxi, when we entered, that time the agent will wish you. He will wish you, then he will start the music which is of your favorite playlist, which is from your favorite playlist. So, if you do so, the customer will be happy, and that corresponding action you have to take. This is an best example of utility based agent. Points to be remembered here are: the agent may have multiple action of sequences that arrive at goal. It chooses an action that provides the best level of happiness for the agent. Utility function will map states to the major. As we know that it is not easy to develop an agent which will work in the real world, because we know that the real world is partially observable, it is not deterministic, it is stochastic, and you cannot determine or you cannot actually cope up with the live environment. If so, we are in search of an agent which will learn the environment or adapt the environment automatically. Such an agent is called as the learning agent. Learning agent has four important components: critic, learning element, problem generator, and performance element. Now, what is an learning element? The learning element is responsible for making the improvement, and performance element is responsible for selecting external actions. The performance element is what an agent that we have described earlier. So it is an entire agent. It takes in percepts and decides on action. The learning element uses the feedback from the critic on how the agent is doing, and it determines how the performance element should be modified to do better in future. The learning element will give the learning goals to the problem generator. Problem generator is responsible for suggesting actions that will lead to new and informative experiences. To understand the working of all these characteristics, we will take an example of automatic taxi driver agent. From the environment, the automatic taxi driver agent is sensing, and whatever it has sensed will go to the critic. Critic will provide you the feedback. Suppose an taxi driver agent has driven a car very harsh. In that case, it will provide a negative feedback. Suppose there is an speed breaker and taxi driver agent has easily crossed that speed breaker. In that case, it will give the positive feedback. Suppose you are making a quick turn which is not safe. This is again a negative feedback to the learning element. The learning element will change the performance element accordingly. And the performance element is also going to feed the knowledge to the learning element. After that, learning element is going to feed various goals to the problem generator. Problem generator will try various or it will try to improve the performance of the performance element by checking various or by trying various problems. For example, if we consider the road conditions, how there are multiple roads like single lane road, double lane road. Sometimes the roads are not proper. They are rough. They are having rough surface. So in that case, how you should drive your car? So that problem generator will provide the thing or information to the performance element. Similarly, we can try out different brakes or brakes on different road surfaces. What happens when you apply the brake in rainy season? What happens when you apply the brake when you are too close to the speed breaker? All these things will be tested here by the problem generator, and the performance element is going to become or it is going to become more adaptable to such a conditions, and based on that it will take an action. Corresponding actuators will work in the environment. So this is what is an learning agent. It is a continuous process, that is, always the sensors will give the feedback or they will give the input to the critic, and critic is going to give the feedback to the learning element. So the learning element is getting positive as well as negative feedback which are required to improve the performance of an agent. So as the situations will arise, Based on that, the learning element will improve the performance of the performance element, and such a type of agent is called as your learning agent because it is learning automatically. Things to be remember, learning agent components are performance element, learning element, critic, and problem generator. One has to try to develop an learning agent always to cope up with the current scenario. So, we have seen various types of agents. Thank you.